Okay, well, we probably ought to get started. My name is Rob Reinauer. I'm the product unit manager for the SQL Systems Engineering Group at Microsoft in Redmond. And some of y'all may not be familiar with how the organizational structures work at Microsoft. A PUM, or a product unit manager, not prisoner of Her Majesty's. A PUM is where development, test, and product management come together, and so we're able to drive a single mission. And so we're a fully provisioned product unit able to go out and build products and define them, and from a requirements point of view, define them and take them to market. So what I'm going to be talking about is the database consolidation solution, which is terminology that I have been coached on to use. Well, it's already been made public, so I'm not going anywhere that I'm not supposed to go, although I probably will later. The database consolidation appliance is actually what I'm talking about. And so this is an appliance product that we are building with HP. There's other hardware vendors in line that we will ship as a full solution. So I'm going to be very careful to use the word solution throughout this because we have not actually formally announced the appliance yet, although we have announced, as it turns out, that we are going to do the appliance. So I'm not really getting into too dangerous territory. But throughout here, you'll see that I've been very careful to use the word solution, which is a reference architecture. But have no fear, we are within a couple of months of this being formally announced and available as a product. So I'm going to talk a little bit about private clouds, sort of what our view is when we talk about private clouds. What are we actually talking about, and what's the value? Why is it relevant? The nature of how my organizations address building appliances. Well, actually, we own both reference architectures and appliances. And I'm not going to spend that much time talking about the reference architecture piece. But we do the reference architectures with a broad set of vendors: HP, Dell, Bull, Cisco, EMC, AMD, Intel. There's a couple in there that I'm missing, but those are sort of the major players. And we're on a subset of those, we're working on appliances. I will then talk a little bit about the database consolidation appliance and what that implementation actually looks like. That specific implementation that we're doing, a consolidation solution, that specific solution that we will be doing with HP that's actually not quite announced yet. I'll talk a bit about the hardware architecture of how this guy's put together and how the pieces are wired up and the nature of the balanced solution that we've defined. And I will talk a bit about the software stack and how it is that we build, because a lot of it, really from a private cloud point of view, it's less a hardware story, although you have to have something to run it on. And it's much more about the software stack that provides the automation and gives you this lower cost of ownership that we'll be talking about. We'll talk a little bit about consolidation virtualization. Typically in the past, I would have spent quite a bit of time talking about consolidation virtualization. At this point, I think that I don't really have to convince people that consolidation is something that they should be thinking about. And presumably, I no longer have to fight the battle around, is virtualization something I should even be looking at? But I'll talk about it a little bit. And certainly if there's questions, it's a place I love to go down. Often my previous presentations, I'd spend half hour, 45 minutes talking about second level address translation and why virtualization works now and why we feel comfortable with it from a SQL Server point of view. I will touch a little bit around application deployment and compatibility and the capacity planning assumptions that have gone into this. But frankly, by the time I get to that point, I will have discussed that. It's one of those things you have to define an agenda and you have to run through it. But many of these things are interleaved and multidimensional, and it's sort of hard to talk about some of the earlier items without, frankly, jumping ahead to some of this other stuff. So I suspect by the time we get to the deployment piece, I'm already going to have talked about physical to virtual migration several times, and we'll probably jump right past that into questions. So in my mind, and I think this largely conveys the way we think about it in Redmond, private clouds are actually very, very simple. When you get right down to it, the only point of having a private cloud infrastructure is to provide a radical lowering of the cost of ownership and the maintenance and management overhead for large compute infrastructure. And that's really what it ought to come back to. That's the whole point of doing this, is I have a bunch of nodes with a bunch of different applications with a bunch of different environments, and I really would prefer not to have a DBA per system managing this thing. Frankly, I'd like to have one guy managing a couple of thousand of these implementations. And so that's the capability that we are bringing to bear here in this appliance, in this solution, soon to be appliance. The mechanisms that are involved there, and certainly that I'll be talking about in a little bit of detail, is integrated monitoring and management, the ability to have cascading health models so that I may have 10 nodes, and when I say node, I mean a physical server. I may have 10 nodes, I may have 20 nodes, I may have 300 nodes, thousands of applications running across these, thousands of SQL instances to be more precise, and the data tier componentry that the databases and stored procedures and SQL, the agent jobs and all those pieces that go with it. I should have the ability to monitor that from a single pane of glass. It doesn't really matter whether I've got 10 or I've got 1,000. If everything's fine, I should see a bunch of green lights. And if anything's going wrong, if I have single points of failure that have not taken the system down, but they are single points of failure, those should show up as warnings. And they should show up in a single place. I shouldn't have to go out to every single system and be looking at stuff and monitoring things, or particularly looking at LEDs. I want to have a single monitoring infrastructure. And the same for the management piece, that if I'm changing passwords across 50 systems, I really should not have to go to 50 systems, log in 50 times, and change all that. So this management at scale and monitoring at scale capabilities. Elastic capacity provisioning. And at some level, this is not, even though these are some of the tenets that we have used in designing the database consolidation appliance, this SQL Server private cloud implementation, but these should be the same. You should be demanding these of any vendor who says that they're providing a private cloud infrastructure. They should be providing these sorts of capabilities in some form. So this is not unique to what I'm doing. This is to what my groups are doing. These are sort of characteristics of what a private cloud infrastructure should bring. Sort of the whole point of why even bother having a private cloud in the first place. So elastic capacity provisioning. I should not have to know where a given SQL instance or a given database is living inside my infrastructure. At some level, why should you even have to pay attention to that? It should be the case that you have a set of compute resources and a set of storage resources, and you're pouring applications into this, and the applications go where they need to go. They go where the capacity is, and that changes over time, which gets into load balancing and servicing, but they're sort of related in some sense, that there is a virtualization of this vehicle, this vessel, that the SQL instances are running in, and it should be elastic, both from a given SQL instance may get very, very busy, and as a result require a load balancing event that instances are moved from one node to another, which, by the way, in this environment happens completely online with no dropping of connections, no restart of transactions. It's completely transparent. It just moves the instances from one node to another. But that should all happen in a very elastic fashion, that SQL instances get busy, they quiesce. All of that, there shouldn't be any administrator involved in having to monitor that or move stuff around or of all crazy things, having to, reinstall things on different boxes. It should all just move around in a very flexible manner. And it goes to the other extreme of, at 8 o'clock at night, and the systems become less busy, there should be the capability of having all of these instances migrate to a smaller number of nodes so you can quiesce some of the other nodes and save power. So, elasticity in the way, at some level, it's kind of continuing the virtualization, that the virtualization argument should be consistent across all of the pieces of your infrastructure. The CPU memory complex, I/O, network utilization, all of these are flexible, fluid capabilities so that you never have, one node is super busy with overloaded network, and meanwhile, you've got another piece of the network that's idle, or another node that's just sitting there doing nothing. So it's elastic. Self-service deployment and monitoring. The ability to have, the business unit IT, or even the application owners, deploying the SQL instances and provisioning their environments themselves. And I'll talk about this in more detail, that ideally, self-service actually isn't enough, because we started out down this path, and we're on our second, actually I guess we're on our third version of the self-service provisioning portal infrastructure, where you actually, as it turns out, practically speaking, there needs to be a workflow. You need to have the ability for central IT to sort of take ownership of the whole thing, delegate the ability to the various business units to deploy a certain number of applications, and that they can delegate that authority to other individuals within their organization to actually go do the deployment. So, pulling central IT out of this gatekeeper role where they're responsible for doing all the low-level work. And as so high availability that any of y'all that have worked with clustering, certainly not necessarily one of the more straightforward and intuitive experiences that people will have using Microsoft infrastructure. Actually, we've made that a lot better. It is getting easier and easier, and especially with SQL Server 11, which is a whole other presentation, although I'd love to talk about it if people are interested, which I ran SQL Engine. Before I started this group, I ran the SQL Engine organization for 5 years, I guess, a little more than 5 years. And so I did the end of UConn 2005, I did Katmai R2, and did half of Denali till it was sort of going, and then I started this new business unit. But the ability to have high availability is an aspect of the infrastructure. So in this environment, for instance, the vessels, the virtual machine containers that applications are going to be brought into already have HA pre-provisioned. So when you bring an application in, it's already got HA pre-provisioned, it's all set up. And it's not like something you have to go, become an expert in clustering or database mirroring. It just works. It's just one of the characteristics. If anything, one of the things we're wondering, should we, maybe we should have some pools that don't have HA. At the moment, we really sort of provide HA as a default where everything has availability because, as it turns out, in a virtualized environment, which is a whole other long conversation, it's almost free. Turns out it's not like you have to have another standby box or a standby virtual machine even, because we instantiate those guys on the fly anyway. So you can have basically free HA that's pre-configured, pre-set up, and you don't really pay much for doing it. It's not like you're wasting a bunch of resources having standby systems. And metering and chargeback. So the ability to, with all these different instances in there, and now that you went from a bunch of separate systems that you could sort of monitor and understand how they were being used and who was using them, well, you move all those into a big centralized infrastructure. How do you keep track of who's doing what, and how do you do chargeback, and how you do billing? And I'll talk a bit how we've implemented that, but it's super, super important aspect of a private cloud. So I've already given away my thunder here. And the first version of this, it was introducing the database consolidation appliance, and it made the marketing people nervous. So I'm not saying that. I'm introducing the consolidation solution. But about 3 weeks from now, well, within a couple of months, we'll be talking about the appliance. So it's already running. We've got it in customer sites. We've got 5 customers that have already deployed it. It's very, very real and down the pike. So when we talk about the solution, and appliance as well, although I want to back away a little bit because we have not announced it yet, and it's not available yet. But it is a fully integrated, pre-provisioned, fully installed and configured hardware, software stack. It's a full solution. You literally, this guy shows up, you open the box, you plug it in. There's no wiring. It's all been pre-wired in the HP factory. All of the routing issues, all of the balancing issues, all of the single point of failure. We've got, and I'll show some diagrams, but everything is cross-wired between multiple HBAs, multiple ports, multiple switches, multiple iSCSI controllers. So whether you lose a wire, you lose a network card, you lose an iSCSI controller, you lose a spindle, a disk, you lose a disk controller, you lose any single point throughout there, we're cross-wired and compensating for it, which, if y'all have built this sort of thing before, is a non-trivial process, getting that all figured out. And for that matter, even understanding the wiring diagram is a bit of a non-trivial process. So that's all set up. Shows up in a box. Actually has a couple of little consultants that usually show up to help you, integrate it into your environment. They're not in the box. They come separately. You undo the box, plug this guy in, and within, you answer a few a few screens, because it comes pre-provisioned with Active Directory inside. It's got an Active Directory and a domain built into it so that we can pre-provision all of the users and the permissions. And a lot of the management infrastructure, you don't necessarily want to be visible out into the rest of your IT environment. So it's a self-contained environment So you plug this guy in, establish a trust relationship between the Active Directory built into the appliance, built into the solution, soon to be an appliance, and you're off and running. And I'll talk a little bit more, as it turns out, it's kind of towards the end of the presentation, but it's an important aspect that, one of the first things you have to do is figure out, well, how many SQL instances do I have and where are they and what are they doing? Because one aspect of consolidation is, well, how big a container do I need to put these instances in? How big are they? And you guys may be different than most of the companies we've talked to, but actually, when they have run this tool, it's called the map tool, and we've done a special modified version of it. They're actually a little surprised when they find out where all their instances are and what they're doing and how busy they are and which ones are busy and which ones are not busy. It comes back with a statement around CPU utilization, I/O utilization, memory use, and gives you some feedback around burstiness, how steady state is it versus how bursty is it. And that provides then a mapping, so you then know, okay, I have 800 instances, and those guys are small, those guys are medium, those guys are large, and then it allows you to start pulling them in one by one into the appliance. I will talk various points through here, and certainly it ends up being a lot more. I do a presentation on the reference architectures and appliances, sort of as the theory of how we do such things. Building a balanced hardware implementation is a non-trivial task, and especially something like this. It's a big, 8, 12-core, well, actually 24-core because it's 2-socket. 8 24-core nodes with 40 gigabits bandwidth per blade, iSCSI with about 400 spindles, 380 disks, 15K SAS drives in this environment. Understanding exactly how to build a balanced implementation is a hard task. And so I've got 14 performance engineers, specifically looking just at the scale, performance, and balance aspects of how do you wire these sorts of things together. And when you look at fiber channel versus iSCSI versus SAS, and 3 gig versus 6 gig, and well, how many channels do I have to have? And well, if I'm running a TPCE style OLTP workload, what do I need to worry about? How much memory do I need? Is that too much memory? Is that too much CPU? Do I need more spindles? Do I need less spindles? What we're bringing here, and it's a lot of the value proposition of the appliance effort all up. And the self-service business intelligence appliance is already out in the market. Started data warehouse, which HP calls, I think, business data warehouse. Our parallel data warehouse, which is a massively scalable appliance, which HP calls the enterprise data warehouse. All of these, and I own the hardware pieces of all of those. All of these are providing a balanced solution, where when you buy this and you run the sort of workloads that we have talked about, when you've purchased the system, you end up with an environment that is not wasting resources, that you don't end up having you're bottlenecked on I/O and you've got 50% of the CPU left over, or you've run out of memory and you've got a bunch of I/O left over, or the CPUs are overutilized and you've got you paid too much for disk. So there's an efficiency of purchasing that we provide with this solution. Extremely high level of application and environmental compatibility. When I talk about environmental compatibility, certainly there's traditional app compat in the sense of I don't want to have to modify my application in order to make use of this solution. But there's more in that often it's not just the app compat, it's an environmental compatibility. It may be that you've got binaries, executables that run as part of SQL jobs. It may be, it could be anything, all the sorts of things that may run as part of your environment. You may use some third-party backup utility that you run on the node to run backups. You may have, who knows what it is. You may have some security protocol. You may have a firewall that your agency has implemented that needs to run on the nodes. Whatever. We enable a physical to virtual migration capability. It's an aspect of System Center, although we've tailored it a bit for the solution, that allows you to point a physical box and it scoops out the contents and moves it intact into a virtual machine. The IP addresses are maintained, the addressing's maintained, the drive letters are maintained. As far as the application knows, as far as the SQL instance knows, as far as the clients connecting to it knows, nothing's happened whatsoever. It's essentially undetectable. So it's not just that it's highly compatible, It's that it's a full environmental compatibility. You literally are taking that physical box and you're scooping it up and putting it inside a virtual machine inside this environment. There is, and I'll talk a little bit more about this later, but one sort of surprising aspect, often surprising, it was controversial 2 years ago, it's less controversial now, is that each SQL instance is provisioned inside its own unique virtual machine. So the first response, people say, wow, that's really inefficient, that you're wasting memory, you're wasting disk, that sounds crazy. And I started out as a performance guy back in my early, actually I was a hardware designer, and then I ran performance groups for about 15 years at various companies. And it was actually, that was my first reaction too. It sounded crazy. As it turns out though, when you do the math, 2 years ago when I was first talking about the software stack, actually here, 2 years ago, I announced this initiative that we were going down around virtualization. It was about $75 per VM in memory, and something like that, and if it was expensive SAN for the overhead that you pay for having things in a virtual machine and having a unique virtual machine. Last time I was here, last year, it was down to about $30. At this point, it's below $15. I actually meant to find that specifically before I came in, but I didn't. But I think it's around $12. So it's not free, but it is a declining curve that next year, it's going to be $5. And what you get is the value is extraordinary around resource isolation, the ability to do monitoring, to do chargeback, to move a given load. If you have instances all stacked together, how exactly are you going to move them from one node to another? That's a very, very difficult proposition. There is a determinism around our instances, and I guess I'm partially responsible because I ran that group, but we're fairly aggressive in the way that we go after buffer cache. We really would like to, we don't like to see memory sitting there just generating heat. We try to put it to use as a buffer cache. What that means, though, is if you have 4 or 5 or 6 or 7, 10, 20 instances on a single box, you, by definition, have a non-deterministic state machine. There is no way you're going to ever be able to reproduce the performance problem that you experienced yesterday, today. Not going to happen. There's just no way that you're going to be able to recreate all the dynamics of all these different instances fighting with each other in buffer cache, pushing the memory around. There's just absolutely no way. So it is fundamentally a non-deterministic environment. Inside virtual machines, which on the one hand, it's kind of slightly 1970s that you have a static memory allocation, and at some level it's inefficient because it is the case that one VM may be getting low hit rates on his buffer and another VM is getting high hit rates on his buffer, and the traditional you would like, well shoot, you should load balance and make sure that that other guy gets more memory. But man, once you start doing that, you're into non-deterministic territory. There is no way to understand later what the performance characteristics were or recreate any problems. The billing and chargeback is part of the reason we actually ended up settling on virtual machines in the first place about 3 years ago is because you can't do resource governing at the I/O level. You can't do chargeback at the I/O level. Because we will take, it's not uncommon that we'll have several pages in memory and we're going to do an I/O. We're going to write them out. It's time, we need to blow we're doing a checkpoint. We need to blow the pages out. If we see a couple of pages with a gap in between, we will splice clean data, assuming it's in buffer cache. We'll take clean data, splice it in between those guys so that we can get a single I/O, which I did some extra writes. Now, I wrote an extra 8K or maybe 16K, but it's a single IOP, which, we're talking 3 to 7 milliseconds. So that's, you can do a whole bunch of splice and clean data and still come out way ahead by doing this. But who do you charge? I mean, who do you charge what for? It could have been from separate applications. Some of the data we just put in there on our own. So, the chargeback's almost impossible. So it is sometimes surprising that we would be provisioning each instance into its own virtual machine, but it has a ton of benefits, and I'll get into that a bit more. So balanced hardware and software, I already spent some time talking about that we spent, I guess, about 1.5 years actually in the design phase of this solution. We started out with fiber channel. We ended up abandoning that and moving to iSCSI because of the routable nature of it, and it's so much nicer from a load balancing and from live migration and the ability to move things across because it's routable, and fiber channel is kind of inherently unroutable. So it's all iSCSI at this point. Balanced solution. We are envisioning, and this also raises people's eyebrows because of this, because of the way we've designed this, We envision some between 20 and 50x consolidation densities. So a single node, a single dual proc 12-core system, between 20 and 50 SQL instances running on each of those nodes. And I'll talk a little bit at the end around why there's such a range between 20 and 50. Our earlier numbers, we were a bit conservative. I think, as a matter of fact, I know that we were too conservative. So it's probably 35 to 40. Actually, it may be greater than 50, but what that results in is if you have eight nodes in a system, you're talking 200 to 400 to 500 SQL instances within a single racked environment. Integrated monitoring and management, I talked about this a little bit already. Certainly a characteristic of private clouds that you should be insisting that your vendors provide, separate from us, whoever it is, this ability to build a cascading health model where from the hardware devices, the drives, up through the controllers, up through the chassis, up through the blades, up to the OS layer, into the SQL layer, it should be a single cascading model such that when you see that SQL instance, or for that matter, often people are represented as an application. It maybe it's the HR application or the finance application, the SAP implementation. Basically, if the SAP application shows the light's green, the whole thing is working from the hardware layer through the OS layer, all the way down to the individual drives, to the network connections, to the cross connects, to the iSCSI controllers. So building that full cascading health model, and that's part of what we bring. Automated servicing and patching. Certainly WSUS already has the ability to, and I suspect many of you guys already use it, to bring patches and servicing items into an environment such that you can roll out patches. But WSUS does not do orchestration. It does not allow you to define maintenance windows. And more importantly, although I've actually heard, well, this is not released information, but I've actually heard that they're gonna do some stuff around eventing. But if you've got 500 or 1,000 SQL instances out there, and 2 of them, a patch has failed somewhere, whether it's an OS patch or it's a SQL patch, how surfacing that as an event that can be monitored is hugely important. It ends up being no different than if I've got 400 spindles and one hard drive goes bad, I really don't want to have to go through and search drive by drive by drive to figure out what the problem is. I want it to flow all the way up such that my SAP application now shows a yellow. And I know that one of the VMs that had to do with my SAP application, one of the patching events failed. So we have a MOM pack that ships with it. We'll ship this when we announce it because we haven't announced it yet. But the thing that it does announce, it will surface patching events, patch failures, so that you see them just like a drive failed or any other thing that you're able to, that you have visibility and you have confidence. If everything's green, you know that all your servicing and patching is there and all the pieces work. Transparent automatic load balancing. I talked about this a little bit, and I'll certainly go into more detail when I talk about live migration. Just that, is anybody here that is not familiar with live migration? I'm asking it that way as opposed to, are you familiar? Because I assume most people are at some level. Okay, so hugely cool technology. Another one of those that when I first heard about it, I was like, yeah, right, that seems ridiculous. But amazingly enough, it really is rock solid. It does allow you to take a virtual machine on one node, on one computer node, and migrate it to another node with 0 downtime. And when I say 0 downtime, I mean literally no drop connections, you don't have to relog in, the transactions don't restart. It literally is moving online from one to the other. As it turns out, just to give the caveat, there is about a 3-second freeze after he gets most of the work done. When he migrates the storage nodes over and he moves the connections and he moves the IP over, he does a little either elegant or hack, depending on your point of view, but he like directly edits the ARP table, implements a editor-based reverse ARP and hacks the table so that the guy thinks that his MAC to IP addresses map. But as a result, you've taken a virtual machine, moved it from one node to the other with 0 downtime. And we utilize this for load balancing. We define reserves that we want typically, actually this is one detail we're still arguing about. We don't actually know where we'll be on this. I think it's going to be 30%, that we want to reserve a 30% reserve in CPU, memory, and disk IOPS, not bandwidth, because bandwidth is much less important in what we're doing here. It's about IOPS, number of I/O operations per second that the drive can do. When any of those exceed 70% or exceed that 30% reserve, we will trigger. Actually, there's some semantics around how long. Like if it just happens once, we won't do it. But if it happens 3 times within 5 seconds, or it exceeds it for longer than, I should know this, 7 or 8 seconds. There's a little bit, because we don't want to, just if there's a little burst, you don't want to trigger a load balancing. But if you do it several times within a window, or it runs past a certain, I think it's 8 seconds, we will trigger a load balancing. And I'd mentioned that we've got 40 gigabit per blade. We reserve an 8 gigabit channel just for live migration, so we're able to do very quick live migrations. This isn't something that drags out over 5 minutes. This is a very quick, in the order of 10 seconds or so. Well, we haven't released this, and so that shouldn't be taken as a commitment by Microsoft or its subsidiaries worldwide, but it happens very, very quickly. Self-service portal with workflows for provisioning, that it's not just a self-service portal that you give people permissions to and everybody can go crazy, but it's a workflow with delegatable permissions such that central IT can build an environment, delegate rights to their business unit IT organizations, who then can delegate it to the various business owners. So you're able to push that work away from IT and allow people to do it on their own in their own time. Pre-provisioned HA, I mentioned this around, and I'm realizing as I'm talking about, there's a certain echoing here of me saying what a private cloud should be, and I'm now going through and say, and guess what, that's exactly what we're providing. But the transparent HA is an example as well, that we, as I had mentioned, that we pre-provision the VM pools, even though they haven't even been hydrated yet, they don't exist. But the pool from which they will be instantiated, we've already implemented HA on it, and it's done in the HP factory. So when the thing shows up, when you do a physical to virtual migration, or you use the self-service portal to provision a new application, that guy ends up with HA already built in, with a health model that's using the clustering health model, the looks alive, is alive, query protocol that goes on there, all of which feeds into the cascading health model that's being monitored. Chargeback and billing, I already sort of couldn't stop myself and already went in and talked about this a bit, but certainly this ability to monitor on a per instance basis and be able to do chargeback to the various units. And towards the end, I think I have some examples of the reports. There's a reporting infrastructure that allows you, it already comes with a bunch of pre-provisioned reports that, says here's who did what. As it turns out, not widely known, in Windows 2008 R2, the virtual machines, they already have a chargeback category, a property that's built into it. It just hadn't really been exploited, so it's already there. And so it's really just a matter of filling in the numbers. And discovery and consolidation characteristics. So I'd mentioned the map tool, this ability to find out, well, how many instances do I have, and what are they doing, how busy are they, and where are they, which is a big piece of how you approach starting a consolidation process in the first place. So to step back just a little bit, and this isn't really a presentation on my organization, but there is an aspect, and it is woven through the presentation a bit, around the nature of workloads and really understanding what the workload is that you're trying to consolidate. That is a huge aspect of being able to do a successful implementation here. And at some level, this is obvious, and y'all may even be thinking this is obvious. But you would be amazed how often people don't really understand the workload, and they just go diving in, they just start throwing things in. I view the workload as similar to, in the development process with my guys, doing a design spec. That you should not be starting coding until you actually have a design spec. And you may think it's all in your head, and I'll just get there and I'll just figure it out. Inevitably, people are happy if they do a design spec. If they do a requirement spec and figure out, why am I doing it? Who's going to use this? Why, what's the point? And then doing a design spec that says, and here's what I'm going to do and how I'm going to meet those requirements. That's what the workload and architecture are equivalent to. The workload is really, it's the requirements. What actually is it doing? How many IOPS is it doing? And especially, focusing on the fact that it's IOPS, not bandwidth. That at some level, although there's a very interesting conversation as we move towards flash-based storage, these equations are going to change a bit. But at the moment, it's very much around IOPS. It's around the number of I/O operations that are capable of being done by your I/O subsystem. And understanding that such that when you then do the architecture of the system, when you specify how is it that I'm going to meet those design requirements, that you're actually designing the right thing. And that's, that's what leads to a balanced architecture. And that's what my guys do. I've got a balance of SQL engine guys, because I was running the engine, so I brought a couple of guys over from there. We actually put the SQL performance group into my organization as well, because a lot of what we're doing, has huge performance implications. And they had the best hardware expertise inside SQL, as it turns out anyway. And for better or for worse, I used to run performance orgs, and it does seem like that stuff sticks to you. And once you say that you know performance, before long you end up running the performance groups, whether you like it or not. So we've got that capability in there too, that then allows us to define architecture, which is the design doc. How should I go about solving these problems? Specifying the hardware, and then really it's sort of the last step is the software stack that you lay on top of it. What we bring from the reason we're actually doing this, and it certainly there's a broader conversation that's a presentation I'm not doing at this particular, although I did it in New Zealand, around reference architectures versus appliances. The whole why bother? Why are you even doing this? It's all around. And I really think this is the high order bit is time to value. How from the time where you get budget allocated to go do something, how long does it take before you actually are able to get value out of that environment? And I pulled a bunch of details here, but none of this should be surprising. That understanding the workload, defining the architecture, evaluating alternatives. Should I be doing fiber channel? What speed fiber channel? How does fiber channel actually compare to iSCSI? Ooh, are there queuing delays? And do I need to have, even if it's the same gigabit per second, do I need to have more of iSCSI? And well, how about if I'm doing live migration and I'm using it for workload and I'm using it for the management infrastructure? Well, boy, how do I carve that out? And do I need to do specific delineations of network bandwidth, or can I just let it ebb and flow? Should it be dynamic? Should I be 10K? Should I be 15K? RPM drives? Do I really need to go SAS? And oh boy, if I want dual tail for failover, for cheap failover, God, I guess I do need to do SAS, but boy, how does that relate to SATA? And if I want to have a hierarchical storage environment, how do I, there's a lot of decisions in all of that typically involves people buying stuff and trying it out, and often ending up at the end settling on something, but ending up with a bunch of leftover hardware from their efforts. So what we do is take that process that I really think conservatively is measured in months down to weeks. That we sort of joke that we have taken all of that evaluation and all of the risk and all of the trying things out, which, by the way, many IT organizations don't have the people that have enough savvy to really understand trade-offs between fiber channel or iSCSI and queuing delays on 10 gig versus 6 gig. We sort of joke that we've gone from that process to the biggest latency now is waiting for the thing to ship. And that really is the case, because we've sort of solved a bunch of those problems. We've mitigated the risk. The biggest latency now ends up being once you order the thing, it takes a couple of weeks for HP to build it and for it to show up. I mentioned risk, as you can imagine. And we've seen it ourselves, because we've done several different versions of this hardware architecture, and you think you understand everything, and you build it, and we argue, and we get to a good point, and then you build it, and lo and behold, it doesn't perform like you think. And it's like, oh, I didn't realize that was an issue. It's like, oh, who would have thought? Oh, wow, that's crazy. So we even have taken a couple of turns around this thing to get the thing right. So, and we're fairly savvy guys, at least we like to think we are. We're, trained computer engineers. I got a bunch of PhDs in the modeling side on performance. We would like to think we're one of the more savvy, astute groups in the damn industry, and we still, it takes a couple of times to get the whole thing right. So there is an aspect around risk, and what we bring with the appliances, with the reference architectures, but even more so with the appliances, is a mitigation of risk. That when you buy it, A, you get time to value quicker, and that it's going to be a balanced environment right out of the box. You're not going to have to be explaining later how, oh, yeah, it actually didn't perform the way that we thought it was going to perform because we didn't understand X, Y, or Z, or the vendor said this, but it actually wasn't really right, it's something else. All of that just goes away because we're standing behind that specific implementation. There is a simplicity of operations that because we know what the drives are, because we know what the controllers are, because we know literally what the specific wiring is, we know how the 10 gig connectivities, what sort of transceivers it's using, we are able to build a management and monitoring infrastructure that precisely understands that hardware and build this cascading health model. Now, System Center and Operations Manager provides that now, and plenty of people do this. So it's not like we've invented cascading health models. But, you know, for instance, the reserves, understanding how much I/O capabilities the system have. Remember, it's not bandwidth, it's IOPS. Well, unless you know ahead of time what the specific brand, model, and type of drive it is, how exactly do you automate such a thing and build it in? So we know, because we put it together. It's 146 gig, 15K SAS drive from HP. It does 218 IOPS per second when it's run TPCE. It allows us to build this full cascading health model that very precisely understands it. And for that matter, it means that we can build a MOM pack that understands I'm in a HP database consolidation appliance. And it understands that it's an appliance. And that flows through, I probably should have touched on it someplace in here. It flows through into the support model as well. Somewhere I know I touch on this. But it means from a support point of view, when you phone support, support knows it's an appliance. It's not just a bunch of blades and drives and controllers. When you phone Microsoft support, they understand, you have the database consolidation appliance. And they understand that whole gestalt of what the whole thing is. So both from a TCO operations as well as a support point of view, understanding very precisely what the thing is, means that we can support it and define it and monitor it more precisely. And I've sort of touched on this about 8 different ways that, a balanced system is really just another way of saying efficiency. When we say that you can be confident that you're getting a balanced box, what we're saying is you're not going to overpay for some part of it. You're not going to, actually pay 20% more for everything because you're kind of nervous and you're worried that it may be bandwidth someplace. And you don't have to worry that, on paper, it looked like that would be fine, but lo and behold, I'm completely I/O bound and my CPUs are 10% busy, which is actually a fairly common circumstance. And as a result, when you see the box that you saw, the picture, which I'm actually not really supposed to show, but I did it fleetingly and I didn't really stay on it too long. It has a whole bunch of disks in there. There's a whole bunch of disk drives that come with this environment to support those 8 spindles, the 8 server nodes, which leads to providing this balanced environment. Well, speaking of. So though I'm being very careful not to say the specific version number of the CPU, I also pulled out the amount of memory. And I'm not saying what the disk drive model is. But otherwise, it's that. So that's what the guy looks like. So it's arranged in storage blocks. You can buy it in a half-rack environment that's 4 blades. It's a C3000 blade enclosure using the 465C HP blade. Happens to be using I think actually that already said, if it's a 465, it already know that it's an AMD. So it's an AMD CPU. There's no strategic thing around AMD versus Intel. It just turned out that from a cost and a power point of view, that was a reasonable choice. Actually, as it turns out, the vendor that we're working on the next version of this with will likely go with Intel. But so it's incidental. It just happens to be AMD. So you can buy it in a half rack that has these 2 storage blocks. It does. So you can see that there's these P2000 controllers, 2 of them, each with expansion cabinets of disks. And that's so that we can cross-connect. So each of these guys has 2 dual 10 gig Ethernet controllers so that we can cross-connect. And these P2000s have 2 controllers, each with 2 10 gig slots. So we can cross-connect and then cross-connect on top of that. So whether you drop a controller, you drop a full P2000, any single point of failure, it's cross-wired. And we got ProCurve switches, 10 gig. Actually, turns out we use 1 gig for the management infrastructure just because it's a cost savings. There's a lot of monitoring. HP's got a very, very sophisticated monitoring infrastructure that's built into their products, and we utilize 1 gig as a separate management fabric to monitor all those guys. But that's hardware architecture. So from a connectivity, I had mentioned the cross connections, and I've probably largely already described this, but as you might imagine, between the P2000s This is iSCSI. The white is 10 gig Ethernet. So it's and so there's no fiber channel here. This is all IP based, everything. The VC is for Virtual Connect. HP has a very, very elegant infrastructure called Flex 10 that also has Virtual Connect that allows you to partition, to do hard partitioning and allocation of bandwidth. So you can take a single 10 gig port and make it look like up to 4 physical adapters inside the server. So it allows us to build subnets inside this environment that from the OS point of view, from Windows Server, it actually looks like there's 16 physical Ethernet controllers. And so it makes it very easy to partition out. And so we have a live migration subnet, we've got a management subnet, we've got several, and a bunch of these are teamed for HA. We've got an operations subnet for all the data flows, the applications talk to it. There's a storage subnet that's also teamed. I shouldn't go into details, but it's a lot. It's a good bit of that capacity is around the ability to do the iSCSI storage. And then, as you might imagine, from the P2000, from the iSCSI controllers, we're using SAS connections to direct attach connections, these JBODs, the 2700s. And so you end up with about 99 spindles per P2000 storage complex. A half rack gets 2 of those, full rack gets 4 of them. I don't think I really mentioned it, and we haven't really settled on this, which I guess by definition means it's not released information, but we'll be in the neighborhood of about 10 racks probably. So you'll be able to have a single management infrastructure and grow from half rack to full rack out to 10 racks, still with a single piece of glass. And if you remember from my previous numbers, 20 to 50 times density, that translates, and I probably don't have this math exactly right, but it's in the ballpark of between 160 to 200, 250, maybe 300 instances per per rack. With 10 of those, you're out in the neighborhood of between 2,000, 5,000 SQL instances being managed and monitored from a single instance, a single private cloud with not much management as you add racks. And so as you're adding quantums of 200 to 500 SQL instances, really the management experience stays the same, except you've got more green lights on the monitor. So this is the software architecture, and I'm sure that I have browsed too long here. I've definitely browsed too long here. So I guess I should sort of pick things up, although I've talked about a lot of this. System Center is the management infrastructure, as I've talked about. Ops Manager for the monitoring with custom mom packs that we've customized and integrated. We have SQL Server inside each instance, inside its own virtual machine. These guys could have gotten here through a physical to virtual migration. They could have been provisioned through the self-service portal. They could have been, they could have been installed just through Virtual Machine Manager, because it's not like we don't block off access to the other capabilities. You've bought software, you've bought System Center. The question came up at dinner last night, for that matter. If you want to make use of this System Center to monitor other systems in your environment, to pull them into a single view, there's absolutely nothing to stop you, although we haven't pre-configured that capability. There's a bunch of solution accelerators, the self-service portal that I'll talk about in a little bit more detail. So I think I've talked about the cascading health models. This sort of gives you a visual representation. And this is not unique to what we're doing. This is a capability that comes with System Center Operations Manager already. But we have done some tweaking around the mom packs so that they cascade better, more cleanly. There is also an aspect, there's a very rich ecosystem of mom packs out in the world. I'm hesitant to say every, but just about every application that runs on Windows and just about every piece of hardware that's supported in the Intel execution methodology produces mom packs. Most of those guys really think they're important, and as a result, they've turned on lots of events because they think all their stuff's really important. A good bit of what we actually have done is turned off a lot of those events so that you have a cleaner environment. For instance, the HP guys, which we love them, we have a great working relationship, but oh my God, to those Blade guys, I mean, they throw events every time the fan changes speeds, there's all sorts of stuff that I'm sure if you're an HP guy, you think this is a really important thing, but it really makes it hard to monitor the environment when every single piece of the infrastructure is saying, hey, I'm still here, I'm doing this, I'm going fast, I'm going slow. So we've cleaned that up so that it's, for instance, the CPU, I don't have the list right here on it, but it's, I'm overheating, I've got a memory failure, I've lost my fan, I'm in danger of imminent failure, I'm shutting down. So it's a much smaller set of warnings and actual failure items. If y'all are familiar with Ops Manager, it has a fat client, which is, as you would expect, a monitor, single glass monitoring environment, but it's also got a very rich web interface that is sort of similar. It reminds me of the Outlook web interface to Outlook. It's a pretty good, realistic rendition of the fat client. It's not a completely unique version, and they've got all sorts of different views, some of which I sort of like this 3D one that I'm not sure was actually useful, but it sure is kind of cool looking to sort of show the physical topology of things. I've never actually seen anybody use it, but it looks cool in demos. Configuration Manager I have mentioned already, and that WSUS is pre-integrated into this environment. It's already built in, and it's pulling over all of the patches and service items, but we use Configuration Manager then to orchestrate the maintenance windows and actually run the process. And also, it's Configuration Manager that throws the events if something fails. Like WSUS at the moment doesn't have the ability to throw a mom event to Ops Manager if a patch failed, whereas Configuration Manager does. There's also a whole bunch of stuff in Configuration Manager that we have not done as much exploitation. It comes with the package already around asset intelligence and license management, and that it gives you a very nice picture of all the stuff you have in your environment and where the licenses are and what's up to speed and stuff. Talked about this. I assume we don't have any System Center people. Well, I think they would agree. This is arguably the most ill-branded product ever to have been released from Microsoft. I guess there's a lot, but it's System Center Virtual Machine Manager Self-Service Portal version 2 SP1, and it's like the third version of the name. They keep changing it, and you would think by the third version you would have something a little snappier than System Center Virtual Machine Manager Self-Service Portal version 2 SP1. But it is, as I described, that it's not just a self-service portal, because it's actually leveraging the provisioning engine of Virtual Machine Manager, but it's putting these workflows on top such that a central, that when you install this, it comes up with the central IT role owning everything. You add network, you add storage, you add memory, you add CPU assets, you add virtual machines, and then he can dole those out to the various business units as they request. There's a workflow where a business unit IT person sends a note saying, I would like to deploy the following, and then central IT can respond saying, you can do these, but you can't do those. Here's what you have permission, and he can actually delegate those to other people inside the environment. There's an additional set of solution accelerators that these are free assets you can bring on. Especially, there's a lot of stuff around compliance. These are U.S. compliance standard. I didn't know enough about Australia or New Zealand, but I assume that your agencies also have compliance standards. And I've heard from the guys here that there's a set of solution accelerators that address that as well, but I'm not up to speed on those. There is an SLA dashboard that's provided that allows both looking at availability of the virtual machine, which is interesting, but it also provides what I think is most interesting. I'm not sure if people will do it, but it allows you to do synthetic availability probes. So instead of just saying, is the virtual machine fine, which at some level, if the instance is gone, has died, that virtual machine's loving it, right? That's the healthiest virtual machine you've ever seen. He's got all sorts of resources, but obviously that's not the right answer. So what makes more sense is being able to define a synthetic probe, and the SLA dashboard does, automates this, where it actually is testing the SQL instance and making sure that it really is up, and it's measuring response time, which is a much more realistic way to look at availability. I think in the virtual machine, it's looking at the message loop, which is a typical way of looking at availability of a system or virtual machine. But the perfect example is SQL is gone, and he's like, man, I'm the healthiest VM you've ever seen, which is probably not the right answer from a SLA point of view. I've talked about load balancing and live migration. it's one of these, I knew that by the time I got here, I would have already talked about it quite a bit. But it's worth emphasizing, it literally is when we say no downtime, it's not just like quick downtime or brief downtime. It literally is no downtime, no drop connections, no retries of transactions. It keeps the same IP address. It literally has moved from one node to another, and it's as if nothing interrupted it. Not going to spend a lot of time on consolidation, although often I spent quite a bit of time on this. And there's a lot of different ways to do consolidation. What we have settled upon for the reasons that I've talked about around resource isolation, around the ability to do chargeback, about the ability to make these loads mobile and move them across nodes, what we were saying is virtual machines. And I started that, actually that piece of the announcement I made 2 years ago, I think, at TechEd in LA, that this is officially, we support all of the virtualization without any caveat, without any restrictions, and this is how you should do consolidation. And I've been saying it for years and years and years, and I'm hoping everybody largely believes it at this point, and there aren't still questions around, I don't know if it's safe. I mean, an example, and this is absolutely not an exaggeration. When we went through the testing cycle, we spent about 4 months testing SQL, reporting services, AS, across Hyper-V. We did not open a single bug on Hyper-V. Literally, there was not a single place where we had to do anything. And so, it's sort of anticlimactic, but it really is a solid infrastructure. There is a real issue, which I notice I don't mention here. There is a real issue in that at the moment you're limited to 4 virtual processors, which are a Nehalem core. That's sort of 8 of the Xeon style, but there is that aspect. So if you have loads that need more than 4 cores, you need to wait for a version of Windows which has not been announced, and I probably shouldn't talk about, but it's coming up soon. That situation is much, much relieved. That we end up having a much better story there. I don't know if we've already talked about that publicly, but I'm going to shy away from it. Often I would spend a lot of time talking about the performance aspects of virtual machines, because certainly I started out also. When I first saw these numbers, I thought, I started talking to my guys in baby talk, like, here's how you do benchmarks, guys. Apparently you don't quite understand what's going on. But, and it's a very interesting conversation that I would love to talk to anybody who wants to. I will probably bore you to tears. But it's around the nature of second-level address translation that previous to Nehalem and I think Shanghai, previous to Nehalem and Shanghai, there was a lot of the MMU, the physical to virtual translation, because the reality is, pages, these physical pages are spread all over the place. When you do the translation, not just to a virtual address space, but then again to a virtual machine that's inside that virtual address space, second-level address translation does that all in hardware, does it in MMU. So the page tables have already been modified to have a second-level address translation by the Windows team back for 2008 R2, actually. And the same thing happens on the I/O side, that a DMA transfer, when SQL says, hey, go read something for me, what actually happens is a scatter-gather list gets built that's a mapping of physical to virtual addresses, now has this extra level of physical to virtual, and then another virtual inside that virtual, which is the virtual machine. Ideally, you want that to happen in hardware. You want that to happen as part of the DMA flow. When the controller grabs the bus and becomes bus master and starts strobing addresses, that physical address should be the actual page inside the virtual machine, not just in the virtual address space. So it's a long story, but it's actually pretty amazing how that has worked out. I have to admit that I'm amazed for how quickly both AMD, actually here's a place where AMD beat Intel to the punch, but Intel does the very same thing now, but AMD did get there first. Are there any Intel employees here? Okay, well, y'all should be comfortable. And at this point, it's the same. That from a performance point of view, there's really no difference between AMD and Intel, but AMD absolutely led the charge here. And I think they set the bar. I'm not sure if Intel would have been quite so aggressive if AMD hadn't jumped there first. But as a result, what we're seeing, we're seeing typically less than 1% overhead, but let's call it 1 to 2% to be safe. 1 to 2% overhead from a CPU and I/O point of view for running inside a virtual machine. Now, those of you guys that are running VMware, I know y'all don't actually see this yet. They do have an issue on the I/O side, and that they do a lot of the work themselves as opposed to pushing it to their partners. And they do not have I/O. My understanding is that the I/O MMU capability, the second level address translation in the DMA flows, has not fully moved through their product line. But none of this is patented. None of the actually it is patented, but it's certainly public domain. And you know, it won't be too long before VMware is in exactly the same spot. I'm not sure where they are version level, but you know, effectively, before long, VMware and Hyper-V are going to have the same characteristic that, you know, essentially you have no overhead for running inside a virtual machine. I've already mentioned, I think, that the advantages to running a SQL instance per virtual machine. It seems a little counterintuitive at first because you are spending a little extra memory to do it, but you get the resource isolation, you get execution determinism, you get the ability to move, you know, this granularity from a failover point of view, that if a given instance fails, you know, the failure domain is of that single instance. You don't have to worry about, you know, if I have a bunch of instances inside a virtual machine, the failover methodology of how you move that to another node ends up being very complex. It's not impossible because people do it now with instance stacking, but they have issues often. It's a fairly complex dance that leads you often find instance stacked environments don't actually use clustering failover, although some of you guys may, but I bet you put quite a bit of work into defining how those flows work. By having an instance per virtual machine, it all just becomes easy. The failover dynamics are easy, the load migration is easy because you can just move them over, and charging and build back that frankly is almost impossible to do well if you just are using instance stacking or schema splicing or database stacking. You know, arguably you can't even do it accurately at the I/O level. If you think you're getting accurate numbers, you're probably somebody's estimating or they're fooling themselves. But in this environment, it just falls out for free almost because on a per OS basis, there's actually lots of statistics around I/O and availability. And so I know it's counterintuitive at some level, although 2 years ago it was more counterintuitive. 2 years ago, people were like, I heard rumbling in the audience when I said it, and people were literally agitated, like, what are you talking about? But hopefully it's less controversial at this point. I mentioned our assessment and planning tool. This actually is available for free. You don't have to buy the Consolidation Appliance. It is available out there now. So if y'all are curious about where your instances are and how busy they are, this is available now. What has been changed is that we have modified it to understand the small, medium, and large workload definitions that we use inside the virtual machine deployment. So it actually, not only does it go find the instances and it figures out how busy they are and what they're doing, it actually categorizes them ahead of time into small, medium, and large. So you have a feel for, you know, how much consolidation appliance do I need? How much can I put into this baby? So it understands ahead of time both the capacity of the appliance and how big the instances are. So it'll tell you ahead of time, you know, how it's going to work. I've really already gotten here. This is another one of those that you have to put things in the agenda and have to wait till you get to them, but certainly it's hard to talk about things. The previous items were hard to talk about without mentioning physical to virtual migration. So the way that you get applications inside, physical to virtual migration we think will be a lot. People will just point to existing physical boxes, suck that content into a node. Data tier application using the DAC infrastructure, which has been around for a while. It's just using Management Studio. And of course, deploying new applications through the self-service portal. So, I heard at dinner last night that people had assumed they would be using this sort of environment for new applications. But I think as people understand more about physical to virtual migration and the nature of that environmental and application compatibility, that there'll be more comfort just, you know, taking your existing boxes. For that matter, they can also be VMware. We will do a translation of a VMware VHD over to Hyper-V VHD, or you can actually have that VM instance living natively inside the Consolidation Appliance. Although, as you might guess, we are not leading the branding campaign with this is a way to consolidate and manage your VMware instances. Maybe surprising. So we are close to out of time, and I don't want to spend too much time on this, but it just shows, this sort of gives an idea of how we view small, medium, and large, the size of these pre-built containers that instances move into. We started out looking at Microsoft's IT environment and several of our large partners. As we've actually gotten the solution out, the pre-appliance out into customer environments, we've come to the conclusion that there's a whole lot more little small guys that are doing only like 10 IOPS per second, maybe a quarter of a CPU, and that's why some of these density, the ranges between 20 to 1 or 50 to 1. It's because we're coming to the conclusion that probably there's a whole lot more of these little small guys that don't do a lot of work, and obviously you're going to get a lot higher density with those. So, with that, questions? Sure, way up in the top. I knew that question would come up. And luckily, when I talked about this before, and it was only talking about the software stack, I really was expecting to have all the answers. Given that we're now talking about a reference architecture and an appliance that hasn't been shipped yet, I feel more comfortable saying that a lot of that is still being hammered out, and I can somewhat evade the question. It is the case that there's modifications happening to licensing such that there'll be mobility, so you get existing licenses and move it in. But there's complexity around that I think I probably should defer and wait on. But we will, within a month or so, we'll have a much better answer to is specifically which licenses will you require for the appliance natively, and how will your existing license mobility work? How will you be able to pull those guys in? But my understanding is I think that there's going to be a lot of flexibility, because obviously I think I can say right off the bat that there's not going to be a requirement that you have to buy a whole new set of licenses in addition to all your existing licenses. That certainly we realize that's ridiculous. Right there. Good. Should have. At one point there was a version of this where I had that in, but this is a shorter. I'm doing a bunch. So the question was, how does it handle existing HA mechanisms, database mirroring? Did you say clustering as well? Yeah, geocluster. So all of those are fully supported. You can certainly use database mirroring in this environment if you want to. You could actually use database mirroring between virtual machines. You could use database mirroring to other nodes outside of the consolidation appliance. And as a result, the DR answer for this appliance in this version is exactly that. That's using existing mechanisms that we have, database mirroring, log shipping. From a geo point of view, there are, I don't want to talk about, there's aspects that we have not announced here that I think I should just wait on. But the easy answer is that we support the existing mechanisms as is. And I really should have mentioned that already, actually. What else? Right there.
How far back do you go with support for the OS and versions of SQL virtualized?
So we will support you migrating anything you want. It could be version 6.5. Now, you will find that the HA behavior on 6.5 is not quite as sophisticated as the behavior on 2008 R2. But certainly, you can scoop up anything. You could scoop up VMware. You could scoop up Linux and pull it in. You can certainly, it doesn't have to be a SQL instance. It could be app servers. It could be whatever you want, because it is a virtual machine. Physical to virtual migration allows you to pull it in. But the transparent HA that we're providing in the monitoring is making assumptions around, that it's a SQL instance. And as SQL has moved along, we've gotten better and better in how the MOM packets interact, and especially how, if you're familiar with the resource DLL and clustering, the is alive, looks alive, is alive, it's pretty darn primitive in the earlier versions, and it gets better and better and better. So that the transparent HA, arguably, if you're, I'm glossing over here, but basically, if you're SQL 2000 and earlier, you're probably, the health is going to be a VM health as opposed to instance health. It's not clear that you really get much in the way of an actual active SQL-based HA, cascading health model.
It's basically to get rid of old hardware initially to give developers time to actually implement new solutions.
That's a very good point. So the point that was made is that you can get rid of the old hardware and move the pieces over, and then I sort of interrupted before you even got to finish.
It gives me the opportunity to get the developer to come in and actually then redevelop the database and actually move it.
Well, and what's nice is once you move these old versions into the consolidation appliance, you're kind of in a different world, because you can take a snapshot. And if you don't, if things don't work out or there's a problem with the upgrade, you can go back again. And that's a capability in the hardware box. You'd have to do backups, and you'd have to test the backups or put in alternate media. It actually becomes a very fluid environment where you can migrate that guy in, get everything solid, everything's consolidated, and you have a monitoring advantage that you are monitoring the health of this unified environment. And then on a per instance basis, as you start going through upgrade cycles, you can take snapshots and you can archive those off to the software library. And if there's ever a problem, months later, you can come back and pull that guy out and be right where you left off. There's a question?
Can you explain a bit about the disaster recovery for this solution?
So the question was, what are the details around disaster recovery for the solution? And it's very related to, I think, our first question, in that what we are supporting for this solution are exactly the same disaster recovery items that we do now. So there is not a unique disaster recovery item that comes out of this. So database mirroring, for instance, is commonly used, certainly log shipping potentially, but probably database mirroring, I would think, because you end up having the zero data loss opportunity, the ability to do synchronous. So we certainly envision that there will be class of applications that don't need DR, and that on a per instance basis, people will implement DR to wherever they need to implement it to. It could be to another rack that's a geolocated. It could be that this guy fans out in a disaster recovery solution to multiple different sites that's implementing failover from all of those guys. But certainly we completely support the existing disaster recovery and synchronous remote secondary capabilities that the products bring now. None of that goes away. Yes, so whether that other box is another consolidation appliance, or it could be that box could be a bunch of separate boxes. It could be different boxes in different cities. We still fully support the ability to do both synchronous and async secondaries out of database mirroring. So you have the ability to do a zero data loss DR failover solution, both as a mirrored implementation or whatever